Hey everyone, welcome back. Alright, before we dive into JdbcTemplate, we need to get some things set up first. Today, we'll create our DAO, make our entity, and get our database table ready. Why do we need to do this? Because a good setup makes working with a database much faster and easier. So, let's get started and set everything up. Alright. As you can see on my screen, we've built multiple employee service APIs, like add employee, get employee, and more. We've come a long way. Now, let's take a closer look at the employee service code. Back when we were learning how to create REST APIs, we were manually generating the employee ID and storing the data in a simple map. It was a good starting point. But here's the thing, that's not how we handle real-world databases. We need to move beyond simple data structures. It's time to level up. Let's bring our skills to the next level. Alright. If you remember, we previously created a class named employee to act as a data transfer object for handling API requests and responses. It served its purpose well. But now, we need a separate employee object in our DAO layer for database interactions. Keeping both classes with the same name might cause confusion. We need to avoid naming conflicts. So, to keep things clear and organized, let's rename our DTO class to something more specific, like employee DTO, to differentiate it from our database entity. Let's quickly do that now. Check out my screen. Okay, the renaming is done. Alright. Since we don't need the main class in our DAO module, let's delete it. Now, let's create an employee class inside the DAO module under the package com.gan.derpun.dao.entity. This will be our dedicated entity class for database operations. Copy all the fields from employee DTO and add them to our new employee entity class inside the DAO module. Okay, we've got a little problem here. The department field in our employee class is an enum from our API part of the project. But since we need to use it in both API and DAO modules, the ideal way is to create a common module and move the enum there. That's the best long-term solution. But, for now, let's keep things simple and just change it to a string type. Done. Now, let's move to another important field, joining date. If we use java.util.date, it won't work right with our database. We should use java.sql.date instead. Alright, let's add a couple more fields to our employee class. First, create date. This will tell us when the employee was first added to the database. Second, modified date. This will show us when the employee's information was last changed. Great. Our employee class is done. But we still need a table in our database. We need to tell our database how to store this data. First, let's make a SQL file for our table. In the resources folder of our DAO module, create a file called table.sql. Okay, first thing we need to do is name our table employee. Now, as you see on my screen, we have an employee ID column. Given its long data type in the application, the corresponding database data type must be bigint. Alright. We need employee ID to be different for each employee, and the database has this cool thing called auto_increment. His makes the database give each new employee a unique ID without us having to do anything. And we want employee ID to be unique for every employee, and the most reliable way to enforce this is by using a primary key constraint. Alright. As you can see on my screen, we have an employee name field of type string in our entity class. Now, let's add this as a column in our employee table. Set the length of employee_name to 100 character. We also need to make sure that employee_name always has a value, so it can't be empty. We'll do that by adding a not null constraint. Next, as you can see on my screen, we have an age field of type int. Let's go ahead and add this column to our employee table. Next, as you can see on my screen, we have a joining date field of type date. Let's add this column to our employee table. Alright. Let's move to the next column, department. This is of type string. But actually, we have it as an enum in our code, containing values like developer, HR, QA. Instead of just using a simple varchar, let's define an enum type directly in the database to ensure data integrity. This prevents invalid department values from being stored. Do same as I do on my screen. Okay, let's look at the created date field now. As you can see on my screen, this field is of type timestamp. And we want the database to set the date and time for us, instead of us doing it ourselves. We'll use default current_timestamp. This will make the database put the current date and time in the created_date column whenever we add a new employee. Alright, now let's move on to the modified date field. As you can see on my screen, this field is of type timestamp. We don't want to manually update this field every time a record is modified. Instead, we want the database to handle it automatically. To achieve this, we'll use default current_timestamp, sets the timestamp when the record is first inserted. Captures the initial creation time. On update current_timestamp, automatically updates the timestamp whenever the row is modified. Awesome. We're done with our create table script for the employee table. Now, let's use dbeaver to make this table in our database. Alright. Check out my screen. The employee table is now in our employee_service database. Let's take a quick look at how it's set up. See all the columns we defined, and there it is. We have our employee ID, employee name, age, joining date, department, created date, and modified date columns, exactly as we designed. You might have seen setups where applications create tables automatically at startup, but we're not doing that here. We're opting for manual control. Instead, we'll manually manage our database, either by running SQL scripts directly in dbeaver. This gives us direct database interaction, or inserting data through our API. This ensures data integrity through our application logic. Alright, before we jump into the JdBC code, there's one last thing we need to take care of. See, our DAO layer is working directly with the employee entity, which is mapped to our database table. But in the API layer, we are using employee DTO to send responses. Now, the problem is, these two are different objects. So, we need a way to convert between them. Whenever we fetch data from the database, we need to convert employee to employee DTO before sending it in the response. Similarly, when we receive data from the API, we need to map employee DTO back to employee before saving it. To do this, we'll create a mapper class that handles this conversion automatically. Alright, let's implement this now. Let's create a generic interface called Entity DTO Mapper. This will help us seamlessly map between entity and DTO. Inside it, I'll define two generic types: E for entity, D for DTO. Now we need two functions. First, we'll have to DTO. This will turn our employee database object into an employee DTO API object. To make this conversion more flexible, we are going to use Java's functional interfaces. This allows us to write Lambda expressions later. Similarly, we have toEntity. This function will do the reverse. It will take an employee DTO and convert it back into an employee. Alright, now that we've set up our Entity DTO Mapper interface, let's move forward and create Employee Mapper. Implement Entity DTO Mapper Employee DTO, meaning it will handle the conversion between employee entities and employee DTO objects. Override the method. Alright. Before we write the toDTO and toEntity code, let's add some Lombok magic to our employee class. I'm adding at data, at all args constructor, at no args constructor, and at builder. Done. Now, let's write those methods. First, I'll implement toDTO. This method takes an employee object and maps it to an employee DTO object. Watch carefully as I populate the DTO fields using data from the employee entity. Now, let's do the opposite. I'm writing to entity, which turns an employee DTO back into an employee object. It's pretty much the same code, just the other way around. And we're done. Now, our mapper can easily transform between employee and employee DTO. Alright, now mark this class as a Spring-managed bean so that we can inject it wherever needed. Alright guys, I know this video is getting a bit long, so let's wrap it up here. In the next video, we'll dive into JdbcTemplate and see how we can use it for database operations. So far, we've done some really important stuff. Created our employee entity. Mapped it to the employee table. Built a mapper to convert between employee and employee DTO. Next, we'll focus on writing database queries using JdbcTemplate. It's gonna be fun. Make sure to like, subscribe, and hit the bell icon so you don't miss the next video. See you soon.